students, today I am going to make the video on crystal field theory in tetrahedral complexes, that is crystal field splitting in tetrahedral complexes. So before going to watch this video, my request you to watch the video which I have made on crystal field theory basics, because in that particular video I have clearly explained what are the d orbitals in which the electrons are sitting along the axis and what are the d orbitals in which electrons are sitting in between the axis. Each and everything I have explained in that particular video very carefully, very easily I have explained. So before watching this video, do watch that video. Now coming to our crystal field splitting in tetrahedral complexes. So before going to see how the splitting happens in the tetrahedral complexes, first of all we have to know how the ligands are attached to the metal in the tetrahedral complex. The ligands are attached to the metal in the tetrahedral complexes in between the axes, in contrast to the octahedral complex. In the octahedral complex, what happened? In the octahedral complexes, the ligands are attached along the axis, whereas in the case of tetrahedral complexes, the ligands are attached in between the axes. Now let us see how they are attached. So this is the metal, and this is the x-axis, this is the y-axis, and this is the z-axis, x, y, and z. Let us extend the axis. Now this is x-axis, this is y-axis, and this is z-axis. Now how the ligands are placed in this? So the ligands are placed in between the x-axis, that is, this is how they are placed. In between the x-axis, one ligand, in between the x-axis, another ligand. Next, in between the y-axis, in between the y-axis. So the ligands in the tetrahedral complexes have been placed in between the x and y-axis. Right. Now, let us discuss about the splitting in the tetrahedral complex with the help of this. Now, the ligands are in between the x and y axis means what? The ligands are approaching the metal in between the x and y axis. Ligands are approaching means what? The electrons on the ligands are approaching the metal in between the x and y axis. Now, what are the d orbitals in which electrons are sitting in between the x and y axis? What are those d orbitals? The d orbitals in which the electrons are sitting in between the axis are T2G set of orbitals, that is dxy, dyz, and dxz d orbitals. Now, since the ligands are placed in between the x and y axis, definitely the repulsions will be there between the electrons on the ligand and the d orbitals which are formed by placing the electrons in between the x axis, that placing the lobes in between the x and y axis. The lobes are placed in between the x and y axis means what? The electrons are placed in between the axis, in between the x and y axis. That is, the concentration of the electrons in between the axis is more. Now, whenever the ligands are approaching the metal, in fact, the electrons on the ligands are approaching the metal in between the axis, definitely whatever the d orbital in which the electrons are sitting in between the axis experience maximum repulsion, and as the repulsion is directly proportional to energy, I have explained this very clearly in the first video on crystal field theory. That is, repulsion is directly proportional to energy. So based upon this, we can say that among the T2G set of orbitals and EG set of d orbitals, T2G set of d orbitals, since in those orbitals the electrons are sitting in between the axes, they experience maximum repulsion, by which they will occupy the highest energy level. On the other hand, whatever the d orbitals in which the electrons are located, or electrons are sitting along the axis, will occupy the lowest energy level. Lowest energy level, right? So with the stuff which I have explained to you, let us discuss about the crystal field splitting in tetrahedral complex. To summarize what is happening in the case of tetrahedral complexes, in the case of tetrahedral complex, exactly what is happening, the ligands are approaching in between the axis. Since the ligands are approaching in between the axis, whatever the d orbital in which the electrons are sitting in between the axis experience maximum repulsion. And what are the d orbitals among the T2G set of orbitals and EG set of d orbitals in which the electrons are sitting in between the axis? Those are T2G set of d orbitals. Since T2G set of d orbitals are experiencing maximum repulsions, as the repulsion is directly proportional to energy, the T2G set of d orbitals will occupy the highest energy level, whereas EG set of d orbitals will occupy the lowest energy level. Let us see the crystal field splitting diagram in this. So initially there will be a degeneracy, already I have explained in the first video on crystal field theory. Basically the metal will be in the ionic gaseous state. Whenever the metal is in the ionic gaseous state, then the energy associated with all the 5d orbitals of the metal is one and same. That is, there is a degeneracy. So among the 5, the first one is dxy, and the second one is dyz, and third one is dxz, and fourth one is dx square minus y square, and fifth one is dz square. So these are the 5d orbitals which are present in the metal, and they are in the degeneracy. That is, whatever the energy associated with these 5d orbitals is one and same. Now whenever the metals are attached to the ligand in the tetrahedral complex, now what happens? The degeneracy of these 5d orbitals is removed, is being eliminated, by which they occupy the average energy level. dxy, dyz, dxz, dx square minus y square, and dz square. dxy, dxz, dyz, dx square minus y square, and dz square. Right. Now, already I clearly explained that in the case of the tetrahedral complex, the ligands are approaching in between the axis. Now, ligands are approaching in between the axis. T2G set of d orbitals will experience maximum repulsion, because in the T2G set of d orbitals only the electrons are sitting in between the axis. Out of this 5, these 3 are T2G set of d orbitals, and these 2 are EG set of d orbitals, right? So now what happens? The T2G set of d orbitals experience maximum repulsion. Since they experience maximum repulsion, as the repulsion is directly proportional to energy, they will occupy the maximum energy level, dxy, dyz, and dxz. On the other hand, we have EG set of d orbitals. If one set of d orbitals are occupying the highest energy level, so definitely the other set of d orbitals will occupy the lowest energy level. What is that set of d orbitals which occupies the lowest energy level? That is Eg set of d orbitals. Eg set of d orbitals. So how many are there? 2 are there. Dx square minus y square and dz square. Right. So this is Eg set of d orbital and this is T2g set of d orbital. And this is the average energy or average energy line, we can write this. Average energy line. Average energy line. Average energy line. Now let us see what is the energy between the T2g set of d orbital and Eg set of d orbital. The energy gap between the T2g set of d orbital and Eg set of d orbital is delta T. Delta T. This stands for tetrahedral complex. Now we have to focus on what is the energy gap between average energy line and Eg set of d orbitals which are occupying the lowest energy level. Right. So same trick. How many d orbitals are there? 5 d orbitals are there. Out of 5 d orbitals, how many are occupying the lowest energy level? 2 are occupying the lowest energy level. So how many are left? 3 are left. And what is happening to the energy of these two d orbitals which are part of Eg set? What is happening? The energy is decreasing. That's why minus. Now let us see what is the energy gap between T2g set of orbitals and the average energy line. The difference energy gap between these two is so out of so totally 5 d orbitals are there. Out of 5 d orbitals, 3 are occupying the highest energy level. The 2 are left. 2 are left. And what is happening to the energy of these 3? It is increasing. So it is denoted by positive sign. Positive sign. So this is the crystal field theory. Crystal field splitting in our tetrahedral complex. This is del T and this is del. So this is about the crystal field splitting in tetrahedral complex. To summarize, so do remember that in the case of tetrahedral complex, the metal is surrounded by the 4 ligands, and these 4 ligands which are surrounding the metal ion approach the metal ion in between the axis. Since they are approaching the metal ion in between the axis, whatever the d orbitals which are formed by placing the lobes in between the axis will experience maximum amount of repulsion, and as the repulsion is directly proportional to energy, those set of d orbitals occupies the highest energy level. And what are the d orbitals among the T2g set of d orbitals and Eg set of d orbitals in which the lobes are placed in between the axis? That is T2g set of d orbitals. Those are dxy, dyz and dxz. That is the reason they are occupying the highest energy level. On the other hand, as the ligand electrons are not approaching the metal electrons along the axis, Eg set of d orbitals experience less repulsion, and as the repulsions are directly proportional to energy, the energy associated with the Eg set of d orbitals is less. Now let us say that this is the average energy line, and in the lowest energy level we have the 2 d orbitals, that is Eg set of d orbitals. So totally 5. Out of 5, 2 are occupying the lowest energy level. What is happening to the remaining 3 are there, and the energy of these 2 is less when compared to the T2g set of d orbitals. That's the reason minus sign is given to this particular the energy gap between average energy line and the Eg set of d orbitals. And what is the energy gap between average energy line and Eg set T2g set of d orbitals? That is plus 2 by 5 Totally how many are there? 5d orbitals are there. Out of 5d orbitals, 3 are occupying the highest energy level. What is happening to the remaining 2? 2 are left. And why the positive sign is given for this? Because their energy is more when compared to the EG set of d orbital. That's the reason positive sign is given. So thank you for watching this video. So if you have any doubts related to the video, please comment those doubts. I will make each and every topic very easy for you. I will make the chemistry piece of cake for you, and that is only possible if you comment on the video. Otherwise I cannot know whether the video is clear to you or not, whether it is understandable or not. So please